A bridge is a parabolic shape which can be modelled by the quadratic equation h is equal to -1/5 times x squared plus 4x, where h is the height in metres above the river and x is the horizontal distance in metres. If the water level is at a height of 0, state the values of x where the bridge meets the river. So the height of 0 means h in the equation above can be substituted for 0, so we're going to solve 0 is equal to -1 divided by 5 times x squared plus 4x. And now you could do that by hand by factorising and solving. However, we're going to use the CAS calculator to solve this. On the CAS calculator, go into the main menu. To solve something, we first need to type the equation in. So we have 0 is equal to negative, and bring up the keyboard and we can use our fraction, 1 divided by 1/5 times x to the power of 2 plus 4x. Then we highlight that and go interactive equation inequality solve, and we want to solve for x, so we press OK, and that gives us our solutions. Therefore, the bridge meets the river at x is equal to 0 and at x is equal to 20. For part B, we want to show that the quadratic equation h is equal to -1/5 x squared plus 4x can also be expressed as h is equal to -1/5 times x minus 10 squared plus 20. So to do this, we're going to need to complete the square. So the first thing we're going to do is take out the -1/5. So we take out -1 divided by 5. And what's left behind is x squared. And if we take -1/5 out from 4x, we're going to be left with -20x. So what's happened there is if we distribute the -1/5 through, you should check that we get back to this original equation up here. The next thing we do is we look at the number that's the coefficient of the x term. So here, this is b, and it's equal to -20. So when we complete the square, we take the b term, which is -20, and we halve it. So that will equal -10. And then we take that term and we square it, which will give us 100. Now we're going to use that to complete the square. So we still have h is equal to -1/5 times all of this expression. And now we're going to have x squared minus 20x. And here we add on the 100 to make a perfect square. Then to maintain the equation, we subtract 100. And then we close our bracket once again. So the trick here is that these three terms form a perfect square. So we can write it as h is equal to -1 divided by 5 times. And then the x, and this is minus 10 all squared, is those three terms. That's the perfect square. And then we still have minus 100. Now this is starting to look like what we want to express it as, but there's still one more step, and that is to distribute this term, which is out the front, and multiply it by both the terms inside the bracket. So that leaves us with h is equal to -1/5 times x minus 10 squared, and then -1/5 times -100 gives positive 20. So we've shown that those two quadratics are in fact the same rule. For part C, we want to state the maximum height of the bridge. And now we know because of this negative here, that means that our parabola is going to look like that, so we will have a maximum height, and that turning point will have a maximum value of 20 from this part of the equation. So the maximum height of the bridge is 20 metres above the water level. For part D, we want to sketch the bridge on the grid below, labelling all axial intercepts and the turning point with their coordinates. So to give us a little bit of a hand, we're going to use the CAS calculator. Next on the CAS calculator, we want to sketch our equation. So if we tap this icon in blue, we bring up our graph screen, and then we can drag our equation, which is a -5 x squared plus 4x, straight into this screen, and it will graph it for us. Now, the graph isn't shown, or the parts that we want to see aren't shown, so we can tap this icon in blue, and we can set our view screen. So we want to start at 0 on the X and go up to 20. And on the Y, we want to start at 0 and go to 25, which is what's shown on the grid. So if we press OK, we'll get a good view of our bridge. And now we want to find some key features. So we can go Analysis, Gsolve, Root, and that will find the X Intercepts. So hitting Execute will put that point on the graph, so that's at 0, 0. Using the right arrow on the hard keypad will bring us to the next one, so we can see the pink part's changed. Hitting execute will put that there, and that's at 20, 0. So those 2 points were actually found previously. And you can see X is 0 and X is 20 up here. And then the last thing we want to do is go analysis, G-solve, and find the turning point. So if we press maximum, we'll find that turning point, which is at 10, 20. And we found that also in part B when we completed the square on the graph. So we now need to copy that out. So we know that we've got an X intercept here at 0, 0, and another one here that is at 20, 0. The turning point is at 10, 20. And now all we need to do is make sure that our shape goes through all these key points. It's going to go through here, and it's going to come back down to our final X-intercept. So that's the shape of the bridge, and we've labelled all the key features with their coordinates. For part E, it says a ship with a rectangular cross-section above the water is approaching the bridge. The ship is 8 metres wide and sits 17 metres above the river water level. We're asked, is it possible for the ship to pass safely under the bridge? And we need to justify our answer. So thinking back to our graph before, if our ship is 8 metres wide, the maximum clearance happens 4 metres either side of the turning point. So we need to look at the value at x equals 6 and x equals 14. So if we evaluate the rule h at x equals 6, we'll have negative 1 divided by 5 times 6 squared plus 4 times 6. Next on the CAS calculator, we want to evaluate this rule when x is equal to 6. So we can drag this rule down, and instead of replacing x with 6, we can go into the keyboard and into Math 3 and use this straight up and down line, which says given that, and we can put x is equal to 6, and it will replace x with 6 for us. So if we hit execute, we find that that is 16.8. And that equals 16.8 metres. So because the ship is 17 metres high and the bridge only has a clearance for 16.8, the ship cannot pass safely under the bridge. If another rectangular shaped ship is 12.8 metres high, what is the maximum width this ship can be to pass safely under the bridge? So this time we're given the height. So if we put that into our equation instead of h, we have 12.8 is equal to negative 1 over 5 x squared plus 4x. And now if we use our CAS calculator, we can solve that for x. Next, we want to solve something again, and this time we have 12.8 is equal to our rule. So we can drag that down to speed things up. And to solve, we highlight our equation and go interactive equation inequality and press solve. We want to solve for x, so that's fine, and press OK. And these are the two solutions. So our CAS calculator gives us x is equal to 4 and x is equal to 16. Therefore, the maximum width of the ship must lie between x is 4 and x is 16, which means that 12 metres is the maximum width of the ship.